Hi there, in this video we're going to cover the basic concepts of probability. And so we'll start with quite a few definitions and I'm just going to highlight the examples. So probability experiment is the actual or trial of doing counts, measurements, or responses that are obtained. So an example of this is a probability experiment consists of picking one M&M from a bag and noting the color. So imagine you have a 1.69-ounce bag of M&Ms and then you reach in, grab just one candy, and then what color is it? So that will be a probability experiment. Outcome, the result of a single trial in a probability experiment. So in the prior example, then an outcome is picking the color yellow. Sample space, the set of all possible outcomes of a probability experiment. So back to our M&M example, the sample space will be all the colors in the bag of M&Ms. So for the just regular M&Ms, green, red, yellow, brown, orange, and blue are the colors that are in the bag. An event is any collection of results or outcomes of a probability experiment. And so oftentimes this is attached with the word probability. What is the probability of the event picking yellow occurring? So the event will be picking yellow, but oftentimes we want to know what is the probability of that event. A simple event is an outcome or an event that cannot be further broken down into simpler components. So the event picking yellow is a simple event because there's only one way to pick yellow for one candy. And I know that may sound confusing because you might be thinking, but there are the other colors in there. Yes, there's red, blue, orange, but if you just reach in the bag and pick a color, there's only one way to get yellow. There's only one, yellow is just one of the other options. So an example of an event that is not a simple event will be you pick 3 candies and then I ask you what is the probability you get blue, green, and yellow. Now this is not a simple event because there are different combinations that you could get blue, green, and yellow, right? The first one candy could be blue, the second green, the third yellow, or first blue, second yellow, third green, and so on. There are 6 different ways that you could get a blue, green, and yellow candy depending on the order in which you pick them. So that is an example of an event that is not simple. Right? You have 6 different ways of getting that event, blue, green, and yellow. Whereas going back to the first one, a simple event, picking yellow, there's just one way to get yellow. And some notation. So we're going to denote P of A as the probability of the event A occurring. And so now we're going to get into the definitions, some different probabilities. So the classical probability, the classical approach, also called theoretical probability, is each outcome in a sample space is equally likely. Then the probability of that event occurring is the number of ways the event A can occur divided by the number of outcomes in the sample space. So back to our event of picking yellow, that was a simple event and is equally likely, meaning yellow can occur. You have the same probability of picking yellow as of picking green or blue or red or any of the other colors. So that's what it means to be equally likely. Every event has an equal chance of being chosen. So the probability of choosing yellow is P of Y equals 1 out of 6 because yellow is one color out of the 6 color choices. Now, a relative frequency approximation of probability is when we observe a probability experiment and count the number of times that the event A occurs. So an example of this will be pick a candy from a bag of M&Ms, note the color, put the candy back in the bag, and repeat that process 10 times, or you're going to do it later for 50 times. Then what is the probability of picking yellow? It will be the number of times yellow came up over the 10 times that you did the experiment. So it's a little bit different than the classical approach, right? Because in the classical approach, we're looking at the number of outcomes in the sample space. So let's go back to where we listed the sample space. The sample space for the bag of M&Ms was green, red, yellow, brown, orange, blue. So the probability of picking yellow when you choose one candy is yellow is one color out of the 6 colors. So that is the classical probability. The number of ways an event can occur, right? There's only one way to get yellow out of 6 colors in the sample space. Whereas the relative frequency approximation is saying I'm going to repeat that process 10 times, picking a candy out of the bag. So how many times did I get yellow over the number of times that I repeated the procedure? So I repeated that procedure in this example, I'm saying 10 times. So that's why I put 10 here on the bottom. Now, subjective probability is the probability of an event occurring is estimated by using knowledge of the relevant circumstances. So subjective probability is often based on intuition, opinions, or estimates. The book actually has a great example of this. It talks about a first date. So it says if Kelly and Mike go on a first date and Kelly asks Mike to guess her age and he guesses too high by 15 years, what is the probability that Mike and Kelly will have a second date? So this is an example of subjective probability, right? It's a probability that is estimated by using knowledge of relevant circumstances. So based on a guess or intuition or opinion, we can estimate that there's not likely going to be a second date. So when you say things are likely or not likely, you're talking about probability. So I will probably say the probability of having a second date will be 0. But again, that is subjective probability because I'm just basing it on opinion or intuition or relevant circumstances. So let's try an example. Decide whether the probability is theoretical, classical, right? The classical approach, relative frequency approximation, or subjective. So the probability of being struck by lightning this year is 1 in 300,000. So what would we say this is? So classical, relative frequency, or subjective? So let's look at the definitions. So classical is the number of ways event A can occur, so being struck by lightning, divided by the number of outcomes in the sample space. We don't really have the entire sample space, right? So probably not that one. Number of times event A can occur, number of times the procedure is repeated. So this sounds more like it, right? The frequency of event A occurring being struck by lightning over the total frequency, total lightning strikes. So this one makes sense, and it is not subjective because it's not based on opinion, intuition, or relevant circumstances. So I will say this is relative frequency approximation. Right, the number of ways that event A can occur being struck by lightning over the total number of lightning strikes. So those are relative frequency. 2, a doctor thinks that the probability the patient will survive the surgery is 80%. So this one, we will say probably that it is subjective because the doctor is basing it in relevant circumstances or intuition or probably experience. But it is subjective. If 2 fair coins are tossed, the probability that they both land heads up is 25%. So what about that one? So let's go back to classical number of ways event A can occur over the number of outcomes in the sample space, number of times for relative frequency, number of times event A can occur over the number of times the procedure is repeated, or right frequency of event A over the total frequency. It's probably not subjective, this one. So 2 fair coins are tossed, the probability that they both land heads up is 25%. So it doesn't necessarily say that a process has been repeated, right? Like the lightning, 300,000 is all the total number of lightning strikes. So probably the classical approach, and we can think of this by make sure of this, I should say, by finding the sample space. So let's try that. So what will the sample space be if you toss 2 coins, fair coins? So you could get both be heads, both tails. You could get heads and tails, and you can get tails and heads. Is that all you could possibly get? Yeah. So the probability they both land heads up would be one. There's only one way of getting that out of four in the sample space. So I will say then this is classical probability, and we can verify. Right, there is one way to get heads out of four in the sample space. And 1 out of 4 is 0.25. And in this case, right, the 0.25 is written as a percentage. Part 4, the probability that a basketball player makes a free throw is 52.4%. Okay, so in this case, for the event is making a free throw. So probably not subjective. So let's see. So it's either classical or relative frequency. Now for classical, we will need to have the number of outcomes in the sample space, which we do not have. So it's mainly, we're talking about this basketball player is throwing the ball. So that's how many, I will say that's the number of times the procedure is being repeated. And then we're keeping track of how many free throws were made. So, or yeah, the event, sorry, where is it? The procedure is throwing the ball, free throws, and then we're keeping track of does he make them or she? So I will say this is relative frequency approximation. One thing to note is that the probability of an event is always between 0 and 1, inclusive. So it can be equal to 0, right? That means it never happens. And it can be equal to 1. That means it always happens. When you convert probabilities to percentage, that means 0%, so it never happens, and 100%, it will always happen. And I will stop there for this video. I'll record a video for the next set of examples. So we're going to try to find this probability. So try it on your own. Express the probability as a reduced fraction, a decimal rounded to 3 decimal places, or a percent. It will be a good practice to do it both ways. Express it as a fraction and then change it to a percent.